So today we're going to look at special cases. Justin, for real, if you can't wake up and be happy, I'm sending you to office. So if you remember when we were multiplying with polynomials, we talked about multiplying special cases. Right? And do you remember when we multiplied them, like the middle term would cancel out, and instead of getting 3 terms in our final answer, we just got 2? So that is the same thing that we are going to be looking at today, except in reverse order.
That's silly when we get party noise.
I'm just going to go ahead and email. Okay, so when we are factoring special cases, we have a few more rules than we've had with factoring other situations. Okay, because they're special, they're unique. Okay, which means when we go to factor a special case, it is going to be 2 terms . It's going to be subtraction. Okay, and the 2 terms are both going to be what we call perfect squares. Does anybody know what a perfect square is? Okay, so I'm going to give you some examples of perfect squares and see if we know. So 1 is the perfect square, 4 is the perfect square, 9 is a perfect square, 16, 25, 36. Okay, Olivia, what do we think?
It's a number that's multiplied by itself.
Okay, so it's a number that we can take a square root of, right? We can find the number times itself that gives us that value. Okay, so here's going to be our sort of definition. We can square root the number. We can really square root any number, but we're just going to accept that when we square root it, we get a whole number, and that makes sense. Okay, for an exponent to have a square root, it's going to have to be even. And we're going to do way more with exponents and square roots later, but for right now, just trust me on that fact. It's going to have an even exponent, and we can square root the number.
What's the last word?
Do what?
What's the last word in the even exponent?
Mm-hmm. Once you know you're in a situation where it's an even exponent, then everything else is good to go. Okay? So let's say we look at 16x squared minus 25. Is this 2 terms?
Yeah.
Yes. Is it subtraction?
Yes.
Yes. So then we need to decide if they're all perfect squares. So
Yes.
what is the square root of 16? 4.
And then 5.
Is this an even exponent?
Yes.
Yes. So to take the square root of something that has an even exponent, you're just going to take half of it. Okay, so we're going to take half of the exponent. Okay, so what's half of 2? 1. What is the square root of 25?
5.
5. Oops. Sorry. We okay with where that 4x and where the 5 came from?
Yeah.
Once you have that info, you're going to make 2 binomials. What's a binomial? 2 terms. Okay, so we're going to make 2 binomials. You cannot change the order. That's sort of the key here. So because 4x is the first perfect square root, we're going to put 4x first in each of these binomials. And because 5 is second, we're going to put 5 second in each of these. Okay, so if you think all the way back to last trimester, when we multiplied these out to get the 2 middle pieces to cancel, one had to be positive and one had to be negative. Right? So that's the same thing here. So one of them is going to get an addition sign, and one of them is going to get a subtraction sign. And that's our answer. Okay, these 2 things, same as first trimester or last trimester, these 2 things are called conjugates. Right? That's the fancy word for binomials that look exactly the same, but one has an addition sign and one has a subtraction sign. Right? And then you can do this then for anything. So once you decide it's a special case, you're set. So let's say we have 100 x to the 4th minus 1.
Yeah.
So is this 2 terms?
Yes.
Yes. Is it subtraction?
Yes.
Yes. Are they both perfect squares?
Yes.
Yes. So what number times itself gives us 100?
10.
10. If you're not sure, so it's easy for 25, right? 5 times 5 is 25. That one's pretty easy. If it starts to get to a larger number and you're not sure, here's how you can use your calculator to help you. You'll take the square root of it, and to do that, you'll hit second, x squared, the number, and then equals, and it will tell you. Okay, so if in your calculator you typed second, x squared, 100 equals, it would tell you 10. Okay, so we're going to take half of the exponent.
That's squared.
What's half of 4?
2.
2. What number times itself gives us 1? 1. Okay, so we'll have 2 binomials. We have to keep the order the same.
And then minus 1 of this.
1 will be addition, and 1 will be subtraction. Yes, Yusuf?
Doesn't matter which one it is.
Sure doesn't, right? Because binomials, we can always flip-flop that order on. So it doesn't matter whether you put the addition first or the subtraction first, as long as you have them both. Are we okay there? Okay, so even though these can start to look really complex, like it is the same pattern, so don't get overwhelmed by it. Okay, it's still pretty straightforward at that point. So 256 is a really large number, but that's okay, because what can we do with 256? Right, type it in your calculator and find out, and it will tell you 16.
Yeah. And then
We'll take half of the exponent, so what's half of x to the 6th?
x to the 3rd.
X to the 3rd.
And then y to
Y to the 1st.
And then
What's half? Oh, What number times itself is 9?
3.
3. Z,
Okay, the second.
2. Does that make sense? That is special cases. Now, I do want to make sure we're okay with this, because this is what gets students all the time. Is x squared minus 25 a special case? Yes. What number times itself is 25?
5.
Half of the exponent.
1.
X is the first, right? How about this one?
Yes.
What will we factor it into?
6 or x plus 6.
Do we agree? X plus 6 and x minus 6?
Yeah.
I don't.
Yeah, wouldn't it?
Why not?
Because it's not subtraction.
Wait.
Does that meet the qualification of it being two terms subtract? No. This is not a special case. So you have to make sure you pay attention to it qualifying before you just start breaking it up. Okay. I don't even know if I would say this last one is a special case. You already know how to factor it. I just need to get you to recall one more thing. Okay. This is a trinomial. This is not what we were just doing. This is something that we should already know how to factor, correct? How do we factor this? 1 times 16, 1 and 16, 2 and 8, 3 and nothing, 4 and 4. Which set are we going to choose? 4 and 4, we agree?
Yes.
Can we use the shortcut on this?
Yes.
Yes. Right? There's no number here. Well, there is. It's a 1. We just don't see it, right? Which means we can use the shortcut. And this factors into an x plus 4 and an x plus 4. And you have factored this correctly, and you're positive you factored this correctly, but you check the multiple choice options, and that is not an answer. Do we know another way to write x plus 4 times x plus 4? X plus 4 squared. So remember last trimester, if we were given this, we knew we could write it twice and multiply it out to get here. So it is very possible that would be the answer that you see in multiple choice.